based on the clock, it is classified as a two types. One is a synchronous and the other one is asynchronous. In synchronous, there is a clock. In asynchronous, there is a no clock. First of all, what is clock? Okay. See, for example, okay, from one device to other device you are trying to communicate now. So you have like only one data line to communicate. So this is data line. In the data line, actual data is transferred. Let's take, as we take an example, we are taking data 153 when you want to transfer from year to year. So using this data line, it is communicated. Now, if you have one more line, this line is called a clock line. So the clock line is used to inform in data line this guy, that is sender, okay, is receiver. So the clock line will tell that what time the receiver has to take the data on this place. It is something like these are all just like a hardware, correct? Now from one hardware to other hardware, the just wire is connected. So again here, how the communication will happen? Either you will be sending 0 volt or you will be sending 5 volt, correct? Now only that is the way. So if it is 1, he is sending 5 volt. If it is 0, he is sending 0 volt. 0 volt, correct? Now using clock, again when based on the clock, this receiver will check this place. If it is coming 5 volt, the received data is 1. Based on the clock, this place he will check whether the coming voltage is 0 volt, means then the received data is 0. Got it, right? So that's how he is taking the data. This you will understand in the Monday class. Monday we are going to discuss about the synchronous serial communication, that is with the clock. So very simple. Very simple. Using clock, the receiver is based on the clock only, this place he will check what data is coming. So you can consider there is a two pipeline. Okay, there is a two pipeline. One end somebody is putting something on that pipeline, and the other end somebody is taking from the pipeline. Okay, no verbal communication, no voice communication. Just you want to understand which time I want to take in the pipe, data pipe. One is you consider data pipe and other one is the clock pipe. So now you are just instead of just you keep looking into the data pipe, what you are doing is whenever for example some ball is coming on the clock pipe, then that time you are checking on the data pipe. So that time in the data pipe, if something is there, some ball is there, then the received data is 1. If no balls are there, then the received data is 0. Got it, right? So again, you are not always, if you keep checking, you will feel nothing is coming, so you will keep thinking that 0 only is coming, 0 only is coming. No. What you are doing is, you have two pipe. Whenever in the clock pipe, you are getting one ball, that time you are checking the same time on the data pipe. In the data pipe, if you are getting ball, then the received data is 1. If you are not getting it, it is empty, then the received data is 0. Again, next time also, when there is a ball is coming on the clock pipe, that time you are checking on the data pipe. If it is ball is there, then you are saying that the received data is 1. If no ball, the received data is 0. Clear? So the receiver, he need not to keep thinking that what time data I have to check. Receiver is clear that whenever clock line I am getting ball, only that time I am going to check on the data pipe. Otherwise he will be keep idle. Clear? Same process is working on this synchronous serial communication. So now using the clock, this both the guy is synchronized. Correct, no? So this guy is putting one ball on the clock. At that time he is putting one data on this. He is putting one ball on the clock line. That time he want to put on the data on this data line. Getting right? So whenever I want to put in the data pipe, no, that time I am putting first one ball on the clock line, then whether I want to put 0 or 1, accordingly I will be putting ball or I am not putting the ball. Got it, right? So that the other end, he will be clear that like when in the clock pipe ball is coming, that time like I will be getting the data. Clear? So this mechanism, when we are transferring for the serial communication, this clock is helping now. Correct, right? Using clock only, these both the guys are talking. Here what is the understanding? Whenever clock line I am sending something, you have to take. Otherwise like you should be idle. Sir, I am not sending anything on the clock line. Then you should keep quiet. Because I am not sending anything. When I am sending something on the clock line, then only you have to check on the data line. Clear everybody? So the clock line is used to make an understanding between both of the sender and the receiver. So it is synchronizing, right? Synchronizing means what? Mutually like each one of them understanding, coming to some mutual understanding, right? So now this guy and this guy is talking with the help of this clock. They are able to understand each, coming to some mutual understanding with the help of the clock. So that's the reason this is called as a synchronized serial communication. Got it, right? So both are synchronized with the help of the clock. Is everybody clear what is synchronized serial communication? How this we are achieving, that we will see in the tomorrow class. Just you have keep this understanding. Now the other one is asynchronous serial communication. So in asynchronous serial communication, there is no clock. You have only one data line. Got it, right? So you have only one data line. Now only one data line you have, then again receiver what he will be doing? See, for example, now instead of 2 pipe, I have only 1 pipe. Both sender and the receiver have only 1 pipe. Then what the receiver will be thinking? Okay, I don't know what time this guy is sending. Then I have to keep watching on the pipe. Correct, no? Then unnecessarily he is wasting the time, no? If somebody is keep watching on the pipe, he is unnecessarily wasting his time. See, whenever like in the clock line ball is coming, that time only he will become active. Otherwise like he will be doing his own job. That is better, right? Now, coming to this synchronous serial communication, whether here no like a clock line, only on the data line, whenever one is coming, he has to go and take it. Whenever, see, we don't know if no data is coming also, we may be thinking that the all data is coming 0, 0. So it is completely like goes what? It's a kind of confused state, like when the data will come, when I have to go and check that particular line. Everybody getting right? For receiver, he will have a confused state that like what time I need to check this data line, whether the ball is coming or not. Got it, right? So for this, there is some set of rules. That rules has to be followed whenever you are using the asynchronous serial communication. See, in synchronous, no need to apply extra rule because already you have a clock line. Using clock line only, this guy is going to check this particular data line. That is very clear. But in asynchronous, no clock line, you have only one line. Then there is some extra rules to be followed when you are using any asynchronous serial communication. Got it, right? So what is the set of rules is? So one example what we are going to discuss is UART is the one example protocol for asynchronous serial communication. First of all, communication means everybody clear. Sending something from here to here or sending something from here to here, that is communication is clear. What is protocol? Set of rules and instruction. Okay, so anything we do, there is some set of rules and regulation. That is nothing but a communication protocol. So when you are sending from here to here or sending from here to here, there are some set of rules and regulation. If you are using UART, that will have some set of rules. If you are using SPI, that has some set of rules. If you are using I2C, that has some set of rules. So which protocol you are using, that rules and regulation you have to follow. Same. When you are studying C programming, it has some set of rules and regulation. When you are studying Python, it has its own set of rules and regulation. Got it, right? So that is what is communication protocol. When you are trying to communicate from ear to ear, for this there are like a 3 different communication protocols we have. One is UART, SPI, I2C. Okay. So UART is asynchronous and these both are synchronous protocols. Okay. So today we are going to discuss about UART. I hope so far everybody clear, right? What is communication and what is serial communication, what is parallel communication. In serial communication again we have 2 types based on the clock. So if there is a clock, then that is synchronous, because using clock both are mutually synchronized. If no clock, then it is a asynchronous. Okay. Now today we are going to discuss about only the asynchronous. Okay. So UART, the abbreviation is Universal Asynchronous Receiver-Transmitter. Okay. So, sir, if there is no clock, then how this communication is going to happen from the sender to receiver? You have one data line. So here assume that this is sender and this is going to be a receiver. Okay. Now here there are some 3 basic rules. That is, one is start bit, start and stop bit, and next data length should be same. Third one is transmission speed. So the transmission speed also called as a baud rate. Okay, let's take one scenario. Same, we have a data 153. 153 we are trying to transfer from device 1 to device 2 using UART protocol. So 153 is available here in some register. And there is a one data line, and here there is a one register. In this register you need to send this 8-bit to here. That's the aim of our discussion. Now when there is no communication, okay, so it means like right now no data is transferred from here to here, then that state we are calling it as an idle state. Got it, right? Because no transfer is happening. It is not that every time the communication will keep happening. Whenever it is needed, only that time the communication is going to happen. So if no communication is happening, that we are calling it as an idle state. So idle state of data line is I. It means there is no communication from sender to receiver, this data line will be always I. It means always 5 volt will be going from here to here every time. Okay, 24/7. If no data is happen, no data transfer is happening, only 5 volt will be keep coming here. So when 5 volt is keep coming, no, this controller or this device, what he will be thinking, he is not sending anything. Correct, no? Because it is always 5 volt is coming. Then the understanding is he is still in the idle state. He is not sending any data. Clear, everybody? So when there is no communication from here to here, it is always 5 volt is maintained here. Next, suppose he want to start this 153, he want to send means, first thing is he has to send a start bit. Okay, so start bit is used to begin the communication. Stop bit is used to end the communication. Okay, so now start bit is going to send means he is going to do from 5 volt to he is going to make it to 0 volt. So start bit is nothing but high to low. So that is already 5 volt is keep coming. Correct? No, that is idle state. So from idle state is putting to 0 volt. So this guy what is making, already is keep sending 5 volt because he is not sending any data. Now he want to send means he is making this 5 volt to 0 volt. So when 0 volt is coming here, this guy will become alert. Correct, no? When 5 volt is coming, he is not doing anything. Now 0 volt is coming means, okay, he is trying to send something. That's the reason he is sending 0 volt. So when 0 volt is coming, he will become alert. That is nothing but that is a start bit. Now the question is, sir, 0 volt he is sending, for how long he will send? Correct, now 0 volt is sending like for 1 hour or half an hour? No. He will be sending for a particular time. The time is based on your transmission speed. Okay, see, microcontroller working speed is different, data transfer speed is different. 20 megahertz is a microcontroller working speed. Got it, right? Baud rate means it is like a data transfer speed. So data transfer speed will be bit low compared with your working speed. So the common baud rate is like a 9600 bits per second. The common baud rate or common transmission speed in UART protocol is like a 9600 bits per second. It means in 1 second he will be sending 9600 bits. So in that case, he is capable of sending 9600 bits in 1 second. So in that case, to transfer 1 bit, how much time he will take? So 1 divided by 9600. If you solve this, you will be getting 104 microsecond. Getting right? So see, in 1 second he is able to send 9600 bits. To transfer 1 bit, I am talking about here this first one you are sending, no? That is 1 bit, right? To transfer this 1 bit, how much time is needed? 1 divided by 9600 if you put, no? You will get for transferring 1 bit how much time is needed. Okay? Getting right? So, ரொம்ப simple இதில் ஏதோ பெருசா இல்லை. ஒரு செகண்ட்ல வந்தா 9600 அனுப்புது. அப்போ ஒரு பிட் அனுப்புறதுக்கு வந்து எவ்வளவு டைம்? ஒரு செகண்ட் டிவைடட் பை 9600 னு போட்டீங்கன்னா you will get the result. Okay? So that is nothing but 104 microsecond. I'll be coming to the again I'll be repeating it. See, in UART is a asynchronous protocol. Asynchronous means there is no clock. If there is no clock, how this communication is established? Because how the microcontroller, how the receiver will get to know now I have to take the data. அதான பிரச்சனை. கரெக்ட்ல? ஒரே ஒரு பைப் இருக்கும்போது நான் எப்ப போய்ட்டு அந்த பைப்ல வர டேட்டாவை எடுக்கணும் அப்படின்றத கன்ஃபியூஷன். Got it, right? If it is 2 pipe is there, according to the clock I will be going and taking the data from the data line. If only 1 pipe is there, whether I have to keep watching on the pipe, that is again I am wasting the time. That's not right. There should be some a proper information. That time I have to go and take it. Correct, right? So If it is like a no clock, then how this UART communication, how this asynchronous communication is established? That is what we are trying to discuss. For that, there are three basic rules. One is start and stop bit, data length, transmission speed. Okay, I will explain one by one. That's what we are trying to discuss now. So, first thing is, when there is no data transfer between sender and the receiver, this data line will be always I. It means always 5 volt will be keep going from sender to receiver. It means like this guy also knows that he is not sending anything because he is just like idle. That's the reason I am keep getting the 5 volt. That is, we are calling it as a idle state. Now he is planning to send something. So whenever he is planning to send this 153, when he want to send this 153, first he has to send a start bit. What is start bit? The idle state is I. From I to making to low is a start bit. Already 5 volt poite irukku. 5 volt ku badala 0 volt nama anupanna. See, you are just alerting this guy. So when you are making it to 0 volt, this guy will become alert. Okay, he started sending something. That is nothing but start bit. Now the question is, how much time I have to send this start bit? Got it, right? The start bit means whether I have to sending like the 0 volt for 1 hour or half an hour. No. So the common transmission speed is 9600 bits per second. It means this guy sending speed also should be 9600. This guy receiving speed also should be 9600. Getting right? Then only this protocol will work. That is what this basic rules. Everybody getting right? So whenever they are using UART protocol, you have to make sure the sender and receiver is in the same transmission speed. Otherwise it is not going to work. Getting right? So whenever I am talking something to you people, whatever I am talking the same speed, you should also receive it. If I am like talking very slow and you are receiving it very fast, it will not work. Or I am talking very fast and you are receiving it like a very slow, it will not work. Got it, right? So let's assume simple way. In 1 second he is sending like a 1 bit, means he also should receive in 1 second 1 bit. If he is sending 1 second like a 10 bit, he is receiving only 1 bit. What will happen? It is not proper communication. Everybody getting right? Okay. Hope everybody following. So that is nothing but transmission speed. So the transmission speed means here 9600 means here also should be 9600. The commonly used transmission speed is 9600 bits per second. Clear? So we are taking 9000. So now for sending 1 bit, this guy, if it is a 9600, sending 1 bit, he needs a 104 microsecond. Got it, right? So now you guys tell me how much time he will send this start bit? 104 microsecond. Got it, right? Because his speed also 9600. It means for him also he will be receiving 1 bit data in 104 microsecond. He will be sending 1 bit in a 104 microsecond. Is everybody getting this logic, right? So he is sending the start bit. Okay, already it is idle state. It means always 5 volt. Now he is sending 0 volt for 104 microsecond. Clear, everybody? So this guy, if 5 volt is coming now, he will just like do his job. When from 5 volt 0 volt is coming, the 0 volt will come for 104 microsecond. Then he will be alert. Okay, so this guy is sending some data. So that first 104 microsecond 0 volt is coming, right? That is nothing but start bit. Is everybody getting right? Very simple algorithm. It's nothing like complex. So just like going 5 volt or 0 volt only. Using that only we are going to tell that guy like what time data is coming. So between these two guys in the data line, if it is 5 volt is keep going, no everybody is idle state, no data transfer. When from 5 volt the 0 volt is going, no, so that time the receiver will get alert. So receiver will start thinking that okay, he started sending the start bit. Again that 0 volt, how much time it will come? It will come for 104 microseconds, because his speed also 9600, his speed also 9600. It is must that both should be in the same speed, otherwise it is not going to work. That's the reason I clearly told these three things should be common. Clear everybody? Start bit. So 104 microsecond, start 0 volt is coming. Next, actually you are sending the data. After 104 microsecond, what data you are trying to send? 1. So 1 means you will be sending 5 volt for another 104 microsecond. Next bit is, so you will be keep checking. See, when the idle state you will not check this. When start bit has come, after that every 104 microsecond you will be checking. If 5 volt is coming, then the received data is 1. Next 104 microsecond, what will happen? So first you transferred a 1, done. Next 104 microsecond, 0 volt will go. So next term again it will come, it will go 0 volt. Okay, so then the received data is 0. So you will be checking another 104 microsecond, 0 volt is coming, so that received data is 0. Again, next 104 microsecond, 0. Got it? So again next 104 microsecond also 0 volt only is coming, so then the received data is 0. Next another 104 microsecond, it will go 5 volt, then the received data is 1. Again next another 104 microsecond, 5 volt will come, then again received data is 1. Again next 104 microsecond, next 104 microsecond, 0. So 0, 0, and another 104 microsecond. Clear? The received data is 1. Got it, right? Now the next 104 microsecond, already 8-bit data is transferred. Already I told the data length of sender and data length of like a receiver should be same. So if this guy is 8-bit data length, this guy also should be 8-bit data length. So that what he will be doing, suppose I'm a receiver, I am working on 8-bit now. So after start bit, I will be waiting for next 104 microsecond only. If my data length is 16-bit, then after start bit, I will be looking into this channel for 104 microsecond. I hope everybody getting this, the concept of data length. So that is a mandatory rule. Sender and receiver data length should be same. Then only this communication protocol will work. Sender and receiver transmission speed should be same. Then only this will work. So if it is 8-bit, I will be I am 8-bit means I will be waiting for only 8-bit. I am 32-bit means if I am 32-bit means I will be waiting for 32-bit 104 microsecond. So after 32-bit, the next data I am expecting it is a stop bit. So now we are focusing on the 8-bit. So 8-bit is transferred here. So after 8-bit, the last 104 microsecond is stop bit. This is stop bit. This is start bit. And this 104 microsecond is a data bits. So the last 104 microsecond is like a I. The stop bit is like a 5 volt. And finally like a no more communication. Then the ideal state of the data line is I. It will remain I. Got it, right? Finally like a no data transfer. So it means like it will be keep remaining for I. So everybody clear, right? So start bit, there is again I'm just recollecting all of this. So when there is no communication between sender and receiver, the data line is I. It will be always 5 volt is going. Now the sender, let's assume this is sender, so he want to start the communication, so he is sending the start bit. So start bit in the sense he will be sending 0 volt. For how much time? 104 microseconds, because our transmission speed is 9600 bits per second. If suppose transmission speed is different, then your 104 microsecond also will differ, because to transfer 1 bit the time also it will differ. So 104 microsecond is sending the 0 volt to indicate that the receiver, boss, I am sending the start bit. So after that 104 microsecond, according to the data length, 8-bit data length is 8 bit, means 8 104 microsecond he is actually using to transfer the data. After that 8 bit, the last bit will be stop bit. Stop bit is I. And after stop bit, the data line will remain idle state, that is always I. Okay. So that's the basic working of your UART protocol. Stop.